All right, it's 1:30. Let's kick this off. Hey, folks, welcome. I'm Priya Sathi. I own data warehousing at Microsoft, and I'm really excited to be here at SQL Pass this year. Lots of exciting announcements in data warehousing from Microsoft, and I'm so glad you guys are here and attending this session. I'm gonna kick this off, and I'm gonna walk through how we're simplifying data warehousing in Microsoft Fabric and helping you bring your data together for the purposes of analytics and AI. And then I'm gonna hand over to my colleague, Joanna, who's gonna take you deep into what we built in this next generation data warehouse. We have some demos, lots of exciting things up here. So with that, I'm just going to ask a question. Raise of hands if you do not know about Microsoft Fabric. Okay, quite a few. Good, because I did prepare a few slides to get started with what is Microsoft Fabric. So let's start there. First of all, Microsoft Fabric is generally available as of today. For those of you that didn't raise your hands, this should be really exciting news. We launched public preview at our Build conference back in May, and now it is generally available. Microsoft Fabric is our unified data and analytics platform, and it is built for the era of AI. It helps you bring together data for the purposes of analytics and AI. It includes a bunch of different compute engines, and I will talk about all of the compute engines that we brought together into a SaaS model built on top of one data lake. By the way, Satya did say that this is our biggest announcement since SQL Server. All right, so let's talk through what exactly is Microsoft Fabric. As I mentioned, AI is only as good as the data that's fed into the AI models. And Fabric is a unified intelligent data platform that brings together everything from what you guys knew about in Azure as PaaS services. This includes Azure Data Factory. This includes Azure Synapse Analytics. This includes Power BI, Kusto, all of these services, or real-time analytics, all of these services brought together as a complete analytics platform, one set of experiences, one architecture, one unified platform, and as I'd mentioned, delivered as SaaS, unlike the building blocks of PaaS that we brought to you in Azure. Second is Fabric is lake-centric and open. What do I mean by that? All of these workloads or compute engines that we've brought together into this unified platform writes and reads data from a lake. This includes data warehousing. This includes Spark. This includes Data Factory. All the data is put into a lake. Well, I'll talk more about that. And all engines write to the lake. All engines can read from the lake. So data is stored in an open data format, and we've adopted the Delta format, the Delta standard. And all engines, compute engines, know how to read and write the Delta standard. The third is Fabric empowers every business user. So at the end of the day, you want your business users to have data at their fingertips. Where are business users doing their jobs? In Microsoft Office applications, Excel, PowerPoint, Teams, SharePoint. And Microsoft Fabric enables empowering you to empower your users, get data very easily in those applications. And it includes Teams. We've talked about AI a lot, and Fabric as well is AI powered from the ground up. We've built all of Fabric with AI in mind. All of our experiences, all of the editors, whether it's a SQL editor, a notebook editor, any of the editors are powered with Copilot experiences, and you will see that across the board. So this is really what Fabric is about. That is generally available to you today. At the bottom, you see we have one data lake. This is what we call one lake. it comes with a Fabric and all of the workloads from Data Factory to data engineering, which is Synapse Spark, powering data engineering and data science. Data warehousing, this is our next generation data warehousing, and we'll talk about why this is very different from other data warehouses in market and even our previous versions. Real-time analytics, we also have, as I mentioned, Power BI and also Data Activator, which is a new service that helps you think about setting thresholds and setting alerts based on what is seen in the data. So you can take business actions based on those triggers. So I'm going to talk about OneLake a little bit so you guys understand this a little bit more. So OneLake, think of OneLake, especially if you've not heard about Fabric. OneLake is literally your OneDrive of data, your OneDrive that comes, with Microsoft Office. It's very, very similar to that. It's a single SaaS data lake. So we've built it on top of Azure Data Lake Storage Gen 2. And this is a single SaaS data lake that is automatically available to the tenant. If you're a new customer, you don't have one, it's automatically available to your tenant. And all these compute engines, the engines on top are purely compute, including data warehousing. We have clearly separated storage and compute, and these are only compute engines. As I mentioned, all of them write. So whether you have a data factory pipeline that's ingesting data from one of the hundreds of connectors we have out there and bringing it in, it's landing that data into OneLake, and same thing with data warehousing and Spark and all of the other workloads. And the data itself, when it lands in OneLake, is in a very intuitive namespace hierarchy. And as the data is coming in, no matter which way, you might have custom code that you've written. That's a Python notebook that's running in Spark. Well, you know what? That data is landing in, it's getting ingested into OneLake. It's automatically indexed, so it's automatically discoverable. We apply information protection labels if the source data had it applied. We are able to do end-to-end lineage, so we can show you that data landed into the data warehouse and there was a Power BI report that was built on top of it, and there's the whole end-to-end lineage. We can also do data sharing. It's set up for data sharing. It's automatically set up for governance and compliance. You don't have to do all of this that you had to do in the previous generations. So this is just one copy of data. The premise here is the separation of storage and compute. No longer do you need to worry about data duplication, data movement to get data from your data lake into your data warehouse, into Power BI, because you want the best possible performance. You don't have to worry anymore about that. All of this is built on the core premise, the separation of storage and compute, and all the engines talk to that one storage layer, so there's always only one copy of data. And as I mentioned, in order to enable this, we've adopted the Delta standard, so Delta Parquet. All the files are getting stored in OneLake as Delta Parquet, and you don't need to worry about doing any of those translations. And we've optimized every engine that works here to work on top of Delta. The last thing is, there are many different engines here. In today's world, if you're trying to manage security, you're going to have to go to one data warehouse, set up security, go to Power BI, set up security, and it's a nightmare. We're also bringing to you a universal security model that's shared across all engines. So whether it's data factory pipelines, Spark, writing data, you can see ultimately all these engines just writing data to OneLake. It's all Delta Parquet, and all of the engines can read it. Now, what about organizations that already have their lakes set up? Many organizations already have built data lakes, and you might have built data lakes in Azure. You might have built data lakes in other cloud. No problem. We also have the ability in Fabric to create shortcuts to those lakes. You could have adopted any data standard. You could have adopted Delta Parquet. I know many customers I talk to have adopted different standards, but you could easily create a shortcut in Fabric from one lake to no matter where that data is residing. A shortcut is nothing but literally like a shortcut on your desktop. It's a symbolic link to that data location. Now, if you have existing, maybe in different clouds, S3 buckets, Amazon S3 buckets, you have some data, you can create a shortcut to that as well, and we will be adding other clouds in the future as well. And this really is the fundamental premise and the promise that you don't have to duplicate data at all. We let you create the shortcut and use it multiple times because the engines don't need to any longer create different versions. And the best part, we support open standards, so we're supporting open APIs, and you can use ADLS APIs as well. Now, that's all fine if data is in a folder, a bunch of files, and you point to that file, and then you want to use data engineering techniques. You want to use maybe Spark or write some code to go harvest that data, convert it into Delta. All of that is possible. But, I mean, what about data that's sitting in databases and other data warehouses? Many customers I talk to have a very complex enterprise data estate. Applications, databases, data warehouses that they've acquired over decades. So in the current in the current enterprise data state, if you have databases and data warehouses, what do you typically do? You go ahead and maybe you have applications that are built on a database. Maybe it's a SQL database. Maybe it's a SQL Server on-prem. You could have Cosmos DB. You could have MongoDB. You could have Snowflake, BigQuery, other data warehouses. So you typically, if you want to bring it all together for the purposes of AI, for purposes of analytics, you're going to have to go extract it, transform it, normalize it, put it into standard, and put it into a central repository. Because you can't create shortcuts, because those databases, as you guys all know, even SQL Server has its own proprietary storage format. Cosmos DB has its own proprietary storage format. Every database has its own proprietary storage. So I can't create a shortcut. So you do the ETLing, right? Extract, transform, load, land it into a central place. But what's the problem with that? Problem with that is that this is not real time, and it's potentially stale, and insights are stale very quickly. It's also expensive projects. There's expensive support costs. So what do data analysts and business analysts and data scientists end up doing? Most likely going and querying the source directly if they're trying to figure out what exactly is the latest and greatest of my orders, my inventory status, etc. So this means you're putting additional pressure on your operational databases, which you really don't want. So we're excited to tell you that very soon we will have a capability included in Fabric called mirroring. So mirroring in Fabric is in private preview. This is going to let you seamlessly connect all your databases and data warehouses in your data estate into Fabric without any ETL. You do not have to extract, transform, and normalize the data. You do not have to write code to convert data to any standards. Do not have to convert to Delta. This is all automatically done, and the best part is this is in near real time, and I'll talk about how that is possible. So, mirroring in Fabric. The core promise we're making here with this capability is we are simplifying your ability to bring data together in your data estate through shortcuts, as I talked about, which is a location to a file folder, but also through mirroring to bring your databases and other data warehouses together into Fabric so you can have all your data together in one central place for the purposes of analytics and AI, because all the capabilities of AI can be used. So any database, any data warehouse can be added in without any ETL. And what you will be able to do is you will get a full database editing experience. Now, those of you that are used to Azure SQL DB, you're using the Azure portal, or maybe you're used to Azure Cosmos DB, you're using the Azure portal, you have these beautiful editing experiences. Right within Fabric, you will see in the upcoming demo that we have beautiful editing experiences off the source database. So you have one central place to go manage your complete data assets. And behind the scenes, what we do is magic. We start, once you set up mirroring in Fabric, we start replicating the data from that source database into Fabric. We create an initial snapshot, and we do the conversions on the fly to Delta Parquet, so it lands in one lick. And we do ongoing incremental updates. Every time there's a transaction, we do incremental updates. And we're keeping data in real time, or close to real time as possible, because we use the database's change data capture technology. Most databases, warehouses today, support CDC, as you guys know, and that's how we're keeping this in sync. What we're also doing, because we're converting it to Delta, now this thing unlocks all of Fabric capabilities for you. Think about, you want blazing fast performance on Power BI. We announced a capability called Power BI Direct Lake Mode, which gives you blazing fast performance directly over one lake, and you have that capability. You want to now query data that's sitting across two different databases. Maybe I have data in Cosmos DB and SQL and Mongo and Snowflake. Well, guess what? I can pull it all together. Or maybe I have my own data warehouses and lake houses in Fabric. I can cross-join really easily now that it's all together without having to move that data myself. And I can use the Copilot. As I mentioned, this is built with Copilot in mind, and you'll be able to use all Copilot experiences across the board. This means your analysts, your data scientists, your users can also now work with real-time data or near real-time data. You created a clear separation. You're getting the clear separation between your operational system and transactions going into your operational system versus system for analytics, serving, and consumption that needs to happen so business users can get insights. You've got that separation. And now the replica that we've created in One Lake separates out those heavy-duty analytical queries that you definitely do not want to hit your operational system with. So I have a demo that now brings all of this together. It shows you all of Fabric experiences that come together, bringing your data in. You can bring your data, write your pipelines, and land it in Fabric if you choose to do so. You can use the mirroring capabilities to not do that heavy lifting yourself and just let us take care of the replication and unlock all of the analytical capabilities in Fabric. So I'm going to play this demo.
Here I am in Fabric in the Fabric Data Warehouse homepage. I now see I have new tiles to mirror data from various databases such as Azure Cosmos DB, SQL DB, Snowflake, and much more. I have a variety of applications in my data estate. My sales transactions are in Cosmos DB. My parts supplier maintains their parts inventory in Snowflake and has shared that with me. I also have a CRM application built on SQL DB. And now with mirroring, I can manage my entire data estate in one place without ever leaving Fabric. I'm going to start by mirroring Cosmos DB data in Fabric. I give it a name, and that's all. I don't have to provision resources, as they're automatically provisioned for me. I pick an existing connection to Cosmos DB, and I pick the database with the sales transactions that I'm interested in. Clicking on Mirror Database initiates the mirroring process behind the scenes to replicate Cosmos DB data into One Lake Delta format. I'm here in a Cosmos DB editor in Fabric where I can directly view all the containers and items I have access to. And from right within this editor, I can even start inserting or uploading new items without leaving Fabric. Any transaction possible in Azure Portal is possible here. I can write queries, and I can view the count of the items I just uploaded. Now, to verify that I have indeed uploaded the data in Azure Cosmos DB, I write the same query in the Azure portal, and I see that my results are the exact same results. Mirror databases automatically come with a SQL Analytics endpoint that enables me to have a unified warehouse and BI reporting experience over the data. I can write T-SQL queries to analyze the data, and I can see the count of the tables I had just updated. Or if I don't know how to write code, I can use the visual query editor to build my queries by just dragging and dropping tables into the canvas and performing complex joins between tables with just a few clicks. Now, Fabric provides me with granular controls and monitoring capabilities. I can stop mirroring at any point in time. I can also click on Monitor Mirroring and look at its status. I can see status of each individual table, when it was last refreshed, and if there were any issues. I can also configure monitoring in detail. I can choose to mirror all of my tables like I did initially, or I might have temporary or staging tables that I may not want to mirror. I can sub-select specific schemas or tables to mirror. I can also see if there might be any issues mirroring tables from the source before I start mirroring. Now here's my workspace with all my mirrored databases I need for my analysis. I can use Fabric warehouse capabilities to create a virtual warehouse. I open my SQL Analytics endpoint, and I can go ahead and easily add my mirrored databases. Choosing New Warehouse shows me all the mirrored databases and the SQL Analytics endpoints and warehouses and lakehouses that I have access to. And I can add these to my Object Explorer. I can see all my tables and from all of my mirrored databases. And I can now just use the T-SQL editor to write a query that joins across all my sources, my Cosmos DB, my SQL DB, and my Snowflake database. And it was just that simple. Fabric enables me to easily share my mirrored database or the SQL Analytics endpoint with users in the organization. I can empower various personas like BI analysts or data scientists to tap into this data for data enrichment and analysis, all on real-time data. As a data scientist, I can easily create a lakehouse by just giving it a name, and in that lakehouse, I can get started with a shortcut to the mirrored databases, Delta tables, and Parquet files. And that was it. I picked the tables that I've been given access to in the mirrored database, and instantly a shortcut is created. There is absolutely no data movement. I can see all the data in the Delta tables. I can also view the underlying Delta log and Parquet files. Now in just one click, I can create a notebook and start analyzing the data and building models using the most recent data. Now, as a BI analyst, I'm in the Data Hub, and I can see the data sets of the mirrored databases shared with me. Clicking on this, I can start creating a report. I can easily view all the tables, all the fields, and start building Power BI reports like I normally would. Now back in my source database, as my data is getting inserted, real-time updates are being made in the replica in Fabric. Here, a new item was just inserted into Cosmos DB, and I can go ahead and verify the count. Now go into Fabric and I run a T-SQL query, and I see that the count has gone up here as well instantly. I go to my Power BI report, and as soon as I refresh it, I see that that count has gone up here as well. In summary, mirroring in Fabric makes it easy to manage my data estate in one place. At any point in time, I can use the replicated delta tables to get real-time insights.
All right, now that we've got all the data together, you guys have seen the demo of how we've simplified data warehousing in Fabric. I'm going to transition over to Joanna, who's going to now go deeper into this next generation data warehouse and get into the architecture.
Thank you, Priya. Hi, everybody. My name is
Here I am in Fabric.
We don't want to hear that again. Okay, so my name is Joanna Podgoretsky, and I'm a product manager here at Microsoft. Priya's my boss, so I better do a good job for you guys today. So what I'll be talking to you about today is basically how we get this amazing performance by virtue of the architecture choices that we've made in Fabric Warehouse. So I'm going to talk to you about this concept of no knobs performance that you may have heard us talk about before, and how we accomplish that no knobs performance at any scale. I'll also talk to you about the storage engine and how we actually achieve that open storage format, and sort of kind of get down into the weeds a little bit. So are you guys interested in that? Yes? Awesome. Okay. So no knobs performance. So let's talk about what we mean by performance at scale and how we accomplish this no knobs performance. Let me remind you that we have been in this business for a very long time. When it comes to query optimization, we have a very mature query optimizer that has been time tested, and you probably have used plenty of times in a lot of our product offerings that you probably have a lot of familiarity with. So if you look at how we accomplish single node performance, it's really a combination of the query processing throughput and this time-tested query optimizer. So we have awesome single node performance, which is time-tested, and probably everybody knows about that is a fact. When you multiply that by the ability to scale and distribute that processing power across multiple nodes, then you really get this performance at scale that we talk about. How do we do that? We do that through a variety of different technologies. So I've already spoken a little bit about the query optimizer, and I'll talk to you a little bit about how the query optimizer works in following slides. We also use the VertiPack engine, which is also a time-tested in-memory columnar processing engine, which has been around, I think, since 2008. It's really good at achieving high compression ratios and reducing memory footprints and improving query performance. It's really good at doing things like predicate pushdowns. And then we have a distributed query processor, which is based on Polaris. So Polaris is the only petabyte scale benchmark published in the industry, and that's what our distributed query processor is based upon. So we have these three time-tested, solid technologies that we incorporate into our Fabric Warehouse solution. So let's take a little bit of a deep dive into the life cycle of a SQL query. Who here runs SQL queries? Woohoo, everybody. This is great. I'm talking to the right people. So think about a select statement or any ingestion command or anything that you're going to run, right? Let's talk about how Fabric actually accomplishes your query result, right? So here we have a query being executed. That query is sent to the SQL front end, okay? And you'll notice down the bottom there, we have a whole pool of back-end compute nodes. That back-end compute node is technically infinitely scalable, which means we can provision as many compute nodes as you need for us to execute your query as quickly and efficiently as possible. So that query gets sent to the SQL front end, and we have a query optimizer, and that query optimizer is basically responsible for generating a query plan. And we are really good at doing that because, as I said, we have this query optimizer which has been in market for over 20 years. Query optimizer is a cost-based estimator that's going to produce some query plans, and it's going to choose the optimal query plan with which to execute your query over those multiple compute nodes. But it doesn't stop there. It actually breaks the query down into tasks, and then it sends it to our distributed query processor to go and execute those tasks over all of the available compute nodes that we provisioned for you. That's basically how the query goes from the query optimizer through to the distributed query processor. The DQP, or the distributed query processor, is basically responsible for scheduling those tasks. So the query gets broken down into these tasks, and these tasks get distributed across the various nodes that are available for you. And then, of course, the results get consolidated, get sent back to the front end, and your result is returned. So that's basically how we execute your SQL query. Let's talk a little bit about the query optimizer. So the query optimizer is going to give you that optimal performance out of the box, that no knobs performance that we continuously talk about. And it's pretty fantastic because you really don't have to think about much when it comes to query optimization. We create the statistics for you automatically out of the box. We also give you the option to create your own manual statistics. So as soon as you execute that query, we're going to go ahead and we're going to create the statistics if they do not already exist. And the statistics are going to be about the distribution of data in your table, the density value, the average column length, and the overall uniqueness of your data to table cardinality. And then the query optimizer basically reads the metadata that it has available to it about the data that it's querying. It creates any missing statistics. It goes ahead and creates that query plan that I spoke about. And then it goes, OK, here you go, DQP. You have to go and execute this as quickly and as efficiently as possible. So when DQP receives the query plan, it's basically responsible for scheduling across all those various nodes that are available in your compute pool. It's going to create what we call a DAG. A DAG is a direct acyclical graph, and it's basically responsible for, it's quite different to a step-based executor where basically every task gets executed in sequence. It's actually going to break apart those tasks that can be executed in parallel to give you maximum concurrency and go off and execute those tasks at the same time. So you get that inbuilt efficiency of parallel execution, which is going to give you that optimal performance and optimal concurrency story that we have. So once DQB takes these tasks, executes them across all the nodes, the backend nodes, which you saw in the previous slide, basically are responsible for executing those tasks and then delivering the results back to the SQL front end. So that's a little bit about how our query optimizer works. So just to kind of hone in on that, right? So we have the query optimizer and the distributed query processor working together to give you fantastic out-of-the-box performance, all with no knobs. We also have inbuilt caching, so data and metadata is cached. So if we don't have enough space in memory, we basically spill over to disk, and that disk is SSD cache, and we basically use it because it's better to read from cache rather than the remote storage, which is going to be less efficient. So again, built-in no knobs performance with inbuilt SSD caching. Back to talking about the distributed query processor, one of my favorite topics. This is what is built on Polaris. Has anybody heard or read the Polaris white paper? Like 2 people. OK, it's a great read if you're interested in this stuff. So what Polaris basically defined for us and what we've built into the distributed query processing engine is this ability to do elastic scale, as well as resiliency. So as we detect more workload pressure, we will automatically scale up the compute nodes that are available to you in order to execute your queries as fast as possible. If one of those nodes at any time becomes unhealthy, we will basically redistribute those tasks over a different compute node. The DQP is also responsible for scheduling and resourcing. So scheduling gets done at a task level. And as I mentioned, the DAG helps us determine what we can run in parallel to give you that optimal concurrency. And then we also have the ability to do compute isolation. And this is, again, inbuilt into Fabric, so you don't have to necessarily worry about prioritization when it comes to your ETL jobs and your ad hoc querying and your Power BI reports, because we actually intelligently allocate those queries into their own compute pools. So you have a separate compute pool for your ad hoc querying, and then you have a separate compute pool for your ingestion jobs. So you're never going to get that competition between those 2 different workloads. And then last but not least, we are able to achieve workspace isolation because of the way that we can actually allow shortcutting to happen. So just say, in enterprise data warehouses of the past, you would basically have all of your data stored in this one giant enterprise warehouse. And when it came to things like chargebacks, just say you have a finance warehouse and then you've got all of your other departments trying to leverage that data. It was really difficult to figure out who needs to be billed for what. with this workspace isolation, you can basically separate out your workloads and shortcut into the main data and avoid duplication as well. Okay, let's talk a little bit about burstable capacity. So this is something where we kind of give you a bit of extra compute or a lot of extra compute because we understand that every workload characteristic is different for every company. There are some organizations where their nightly ETL jobs run and they demand more resources than other periods throughout the day. And then you have idle time throughout the day. So what we actually do is we give you burstable capacity. So that basically means that at periods of peak load, we will actually give you more compute power so that we can complete your workload as quickly as possible. And then we'll smooth it out during quieter times or more idle times throughout the day. We introduced SKU guardrails recently, which basically put some limits around that burstable capacity. So on average, you're going to get 6 to 12 times the amount of compute units that your SKU allows. So let me walk you through that. So on the right-hand side here, you have your Fabric SKUs. So if I take, for example, an F16 SKU, where I have a baseline capacity unit of 16 compute units. So that could translate to, just say you have a query running, and that query is going to actually demand 100 compute units, which is more than technically you have in your Fabric SKU. We will actually give you that additional compute power that you need to process your query as quickly as possible. So we will burst up to 12 times the amount of capacity units that you have available. It's a pretty good bargain if you ask me. And then one thing to point out about this, so I want to be clear that that doesn't mean that we're just going to give you extra resources when if a query only needs 10 compute units and your SKU only allows you 10 compute units, we're still only going to give you 10 compute units because you already have the compute you need to execute your query as efficiently as possible. But where this is beneficial is when the compute units that you need are a lot higher than what your SKU limits allow. That's when this is actually beneficial. Okay, let's talk about automated storage management and maintenance. So this is a topic where it kind of ties into that no-knobs performance, no-knobs maintenance, and all those sorts of good things. So let's talk a little bit about Delta Parquet, which is what Fabric Warehouse and all the workloads in Fabric are built on. So warehouse tables, as you know, are made up of a bunch of Parquet files with a Delta transaction log on top of them, right? Parquet, as you probably also know, is optimized for columnar format data. So it's optimized for analytical workloads specifically. The compression techniques that you find in Parquet are actually pretty similar to those that we use in the VertiPack engine when we do the encoding of Parquet files. We leverage things like run length encoding, bit packing, dictionary encoding to give you that optimal compression. So not only do we have the benefits of columnar formatted storage, but we also have some of our additional VertiPack secret sauce on top to give you that even better querying performance, which I'll talk about in a moment. And then on top of that, we have the Delta format, which is basically what gives our warehouse that is just built on a bunch of Parquet files that atomicity, that consistency, that isolation, and that durability that we look for in a relational engine, right? So here you can see, and it's open to anybody to, once you have a warehouse provision in Fabric, you can go into your OneLake Explorer and you can actually see those Parquet files in the Files section. If you click on your Table section in the Delta log, that's where you see all your Delta log, and that's what makes your warehouse transactionally consistent. So basically, Parquet files get transcoded into SQL columnar format. And basically, we have this thing called the transcoder, which basically does that encoding from Parquet into columnar storage format, into column store indexes. And that's how we can operate the SQL engine over the Parquet data. And then we, as I mentioned, add our own, we sprinkle a bit of our own secret sauce, which is this V-ordered Parquet files. So all data in a Fabric warehouse is V-ordered, which means that it's optimal for processing using VertiPack. So what we do is on write, we basically apply some additional sorting, some additional run length encoding that you find natively in Parquet to give you that extra boost in performance. So Here, you have on the right-hand side a graph of our own internal benchmarking for TPCH 1 terabyte workloads. And we have proven to ourselves, and also through a lot of customers have been tweeting about this too, about how great the performance has been since we introduced V-ordering in the warehouse. So definitely yields faster results by virtue of the special sorting and compression. Now, in addition to the better querying time, V-ordered Parquet enables us to deliver you direct lake over warehouse, which is another really exciting capability that we just landed. So those of you who are Power BI users, in the past, when you wanted to use your Power BI over a warehouse, you had direct query, you had import mode, each of which come with its own shortcomings. So when you have direct query, it's slow, but you get the real-time data, which is what you want. With import mode, it has a lot of inbuilt latency, and it's duplicating your data, but it is fast. Direct lake mode is perfect because you're basically going direct to the source to read your data. Okay, so let's talk a little bit about this inter-engine interoperability, cross-engine interoperability that you probably have heard us talk about a fair bit as well. So we have lake houses in Fabric and we have warehouses in Fabric. So when you create a lake house, you automatically, for free, out of the box, get a SQL Analytics endpoint, which allows you to query that data. So if you create your lakehouse and then you're querying it, that's basically automatic metadata discovery that we're performing for you. But you cannot perform DML over that. When you ingest into the warehouse, the SQL engine actually owns that data. Therefore, anything that you ingest with a warehouse, you can perform DML. So that's why we have here this concept of the lakehouse, and you can see the SQL engine can read and write to the warehouse. Spark engine can only read, and then for the lakehouse, the Spark engine can read and write, but only SQL can read, and that's because it's the owning artifact that it allows it to perform DML. So what we do within the warehouse is we actually publish Delta Lake logs. We recently introduced the full lifecycle of DML, so you can basically leverage your warehouse through any Fabric engine because we publish deletes, updates, as well as inserts. So up until recently, we were only doing inserts. Again, in the spirit of SaaSification and out-of-the-box performance, we have automatic table maintenance. So you don't have to worry about running any optimized commands. We basically do all data compaction for you. We will do data garbage collection for you shortly, and we will also be introducing checkpointing of those Delta log files as well. So you don't have to worry about any of that. So why do you need compaction? Compaction is important to avoid that small files problem where you have a table, you do a bunch of inserts, suddenly your table has so many Parquet files, so reading that table becomes super slow and inefficient. Compaction gives you that condensation into smaller number of Parquet files. And Priya spoke about virtual warehouses with cross-database querying. So this is basically probably my favorite feature for Fabric warehouses, this ability to create these virtual warehouses. And you can do that through creating shortcuts to no matter where your data resides, whether it's already in Delta Parquet in an S3 bucket, or whether it's in Snowflake or any other engine. With mirroring, you can shortcut into it and you can leverage that data in the one place. Okay. So that's how we perform no-knobs performance at scale, and that's how we basically take the heavy lifting off your plate and we do it for you. Now let's switch over to developer tools. I know that there are some developers, DBAs, data engineers in the audience here today. I can see some people nodding. So let's talk about what developer experiences we have available to you today. So when it comes to CI/CD, you can use the native source control management capabilities that are already available in VS Code and Data Studio to manage any versioning or versioning of your SQL script. So that's already available today. We also will be offering native Git integration directly through Fabric. So basically, you can connect your workspace to Azure DevOps Git repo and do all of your commits, your reverts, and collaborate over that with for your CI pipelines. And then you have your warehouse, which you can export as a SQL project as well. And we just recently also announced support for CRUD REST APIs. So you can do things like create your warehouse artifact, read, list, delete, all those sorts of good things. So that plays into that automation story and the developer experiences story. When it comes to continuous deployment, that's actually already something that is available in Power BI, but we've released for Fabric artifacts as well. So we'll also have the ability to automate deployment pipelines with REST, which is coming early next year. We also have integration with the existing Azure DevOps pipelines through PowerShell, and available now is also SQL package support. So this is basically how you would connect a workspace to a Git repo. So basically, you have it all in the workspace settings of your Fabric workspace. So you can work locally, you can select which artifacts to commit, you can create your pull request, and off you go from there. Deployment pipelines, you can move your artifacts and kind of stage them through different environments. So here you have an example of a dev test prod environment. So you can basically set up any amount of stages that you like, and then you can connect them in the deployment pipeline. You can compare changes between different environments, and then you can basically commit them from there. Let's talk a little bit about migration options. So migration is potentially something top of mind for some of you, I don't know. Hopefully it's something that's on your mind if you're currently using Synapse SQL. So we have a few different options, and we will be evolving the story as we go. But to start off with, we have migration guidance available through a very detailed set of documentation online. You'll be able to, it will address basically how you can do your extraction, the generation of your DDL, and then how you can use like ETL pipelines to populate what you've created. We've also got some code accelerators to do exactly what I just described. So basically, code accelerators are going to be a set of PowerShell scripts, which basically run DDL over all of your tables. And then, so you'll extract the schema using SQL CMD, and then we'll create a SQL projects file, and then it will create a DAC pack, and then publish it to Fabric, and then you can use tools like an ADF pipeline or a copy into command to then populate that as well. And then last but not least is the first-party client tools. We will actually see a demo on how you can actually leverage SQL database projects to do that. Just one second. Okay, and you're going to hear from Salil, who owns developer experiences and CI/CD on exactly how this is done.
In this demo, I will be using the SQL Database Projects extension available inside of Azure Data Studio and Visual Studio Code to migrate my code and data from my existing dedicated SQL pool to my new Fabric warehouse. To start, I have my dedicated SQL pool here full of tables, views, stored procedures, and data, as you can see here. To migrate the contents of my dedicated SQL pool using SQL projects, I first need to open up Azure Data Studio and navigate to the SQL Database Project extension. Now that I have entered the extension, I can create a database project directly from my warehouse. A database project is a local representation of SQL objects that comprise the schema for a single database, such as tables, stored procedures, or functions. Here, I specify my connection strings to the dedicated SQL pool to extract the schema of my existing warehouse. Now that my extraction is complete, I can see the .SQL files that contain the definitions of all my SQL objects. After validating my syntax, I change the target platform to Synapse Data Warehouse in Microsoft Fabric. Now, I am ready to publish my schema to my newly created Fabric warehouse. Here, I specify my target connection string and click Connect. Now, I'm ready to publish. Navigating to Fabric, I open the warehouse that I just created and published to. I notice that my schema has successfully published from SQL projects. However, there is no data within the tables. To migrate the data, I can simply use a pipeline that uses my dedicated SQL pool as the source and my Fabric warehouse as the target. Here, I am immediately greeted with the copy data wizard that makes this experience super easy to set up. I choose the Synapse connector and specify the connection string of my dedicated SQL pool. Then I click Next. Now, I get to choose which tables I want to migrate. In this case, it's all of them, so I click Next. As you can see, the warehouse is already pre-populated as the data destination, so I click Next. Pipelines already automatically configure my column mappings, so I simply choose Load to Existing Table, and I click Next. I verify my settings, and now I'm ready to save and run my pipeline. I can see that my pipeline has started to run and my data migration is in progress. Now that my pipeline has finished running, I navigate back to my Fabric warehouse. And ta-da! I have successfully migrated my entire warehouse schema along with all my data to my new Fabric warehouse. Thanks for watching.
Here we go, super easy. So that's basically the developer experiences, the CI/CD, and the migration story that we have today. I'm going to move on now to monitoring, which is often a very popular topic amongst DBAs. And let's talk about what we have available for monitoring. So we recently introduced something called Query Insights, which basically gives you an entire query history for every query that's basically executed. We have we're monitoring it, and we're basically putting information about it into a data store. So it's going to give you aggregated insights into your longest running queries and queries that are running most frequently. And the query store, it's all built in. You probably have noticed that we started doing that, those of you who are using Fabric already. But basically, when queries are executed, the query store will collect, store, and analyze the telemetry about that query. And we'll actually do some of our own automatic tuning based on this as well. So in the spirit of no knobs and automated out-of-the-box maintenance and performance, if the self-tuner tells us that your statistics are out of date, we will actually update those statistics for you ourselves before you necessarily have to worry about it. And we will build upon that capability to build in more self-tuning over time as well. And then you can access that historical data and workload insights through all of your favorite tools, such as SMS, SQL Queries, Fabric UI, and Azure Data Studio. So let's have a little look at that as well.
As a SQL admin, member, or contributor, I can now come into my Microsoft Fabric data warehouse or SQL endpoint and get query insights inbuilt views like exec request history, frequently run queries, and long-running queries on my fingertips. Here I have a query running on TPCDS that has taken a little longer than 2 minutes to run, and I want to evaluate whether this is normal or whether this query can be run faster, what would the other operations run at the same time. So let's move to the long-running queries view, where I'm trying to order by the total median elapsed time so that I can understand which queries actually took the longest. And if you look here, the same query that we saw before does seem to be top of the charts in terms of how long it has run in the past. It's a elapsed time of about 2.5 minutes. It does look like it ran faster in some occurrences, and if the user is interested, they can go in further to the exec requests view to figure out if the same query ran faster and when that happened, and what were the other operations by looking at the timestamp of the query. Users are also able to see which queries were run most frequently, and this can help them evaluate what kind of queries are the users running, who are the users that are running these queries. And if they need to contact someone about a data set that can be optimized further, or certain queries that need to be run at a different time or in different mechanisms, they can find out who are the owners of these operations and data. Thanks, and hope you enjoy using this feature.
We also have
a
bunch of DMVs available as well, such as DM exec requests, I think DM exec sessions. So we do have some other monitoring DMVs available in addition to query insights. Okay, let's talk about security briefly as well. So security is performed through workspace roles. So workspaces have the admin role, the member role, the contributor role, and the viewer role. So you can basically allocate people within your organization access depending on what level of access you want them to have to that workspace. And then in addition to that, we have SQL engine security. And we recently announced row-level security, column-level security, and dynamic data masking, which are all available and securable through the SQL engine. Once we land our universal security story, that will also flow through to the other engines as well. Okay, last but not least is data recovery, some people's favorite topic, definitely one of my favorite topics. So data recovery, we have two options available today, and we will continuously evolve the data recovery story as well. The first method that we have for recovering your warehouse is something that we call restore in place. So restore in place, we basically, when you have a warehouse, we automatically take system-generated backups for you every 8 hours. That's just out of the box without you having to think about it. And we expire those backups, or they're not backups, by the way, they're basically like snapshots every 8 hours, and we keep them around for 7 days. So out of the box, 7 days, with a limit of 42 restore points. We also allow you to create user-defined restore points. And again, the user-defined restore points are unlimited, and you can create them through REST APIs. So today we have support through REST APIs, so you need to use a tool like Postman to perform your in-place recovery. But soon we will land the UX, so this can be done through the UX, and we'll be landing that very, very soon. The other capability which I'm really excited about is table clones. So table clones with time travel. So when we went into public preview, shortly after that, we released table clones, which allowed you to create a clone of your table as of the current point in time. We recently added to that and added the ability to do time travel with your clone. So you can basically clone a table as of a specific point in time. And that's something that is also a 7-day retention period. So for example, you may have a production scenario where you ran a release 3 days ago, and then you basically want to see what the state of that table was 3 days ago. You can basically clone that table as of 3 days ago and see the exact state of that table as it was. So basically go back in time and give you that the clone table. So that's something that is available today, and again, the 7-day retention period applies. Okay, so we've spoken about the Fabric warehouse. We've gone deep into the weeds about the distributed processing architecture and the query optimizer and the storage formats and all sorts of really exciting things that I hope that you've learned something today from me. What I wanted to talk to you about now is the roadmap. So the roadmap, first off, I wanted to make sure we just touch upon what we announced today in terms of the Fabric warehouse. So we announced a bunch of UX improvements. So we now have the ability to create a clone of a table through the UX in addition to the T-SQL code. We have the ability to save a table, save a view, do a save as view or a table in the visual query editor. So we've made a lot of investments and enhancements into that visual query editor as well. We have support for endorsements. We have better samples available and viewers and shared recipients can also save queries. I mentioned earlier, we've introduced the REST APIs that are available now. We have SQL package support, clone with time travel, and support for SP rename, which I know many of you are eagerly awaiting, as well as that full DML publishing of Delta Lake logs. So the full life cycle of inserts, updates, deletes. We also introduced query insights to enable you to perform monitoring of your environment. Dynamic data masking was recently announced, and data compaction. We also announced a new CSV parser, which by all accounts has made CSV ingestion significantly faster. And that's based on some research we did internally, where we leveraged this awesome new parser, which has been able to deliver these awesome ingestion times. And we've also announced SSD metadata caching in addition to data caching. Coming in the first half of next year are a bunch of new SaaS experiences. So we have the AI Copilot, which is going to land in the warehouse, which is super exciting. We have notebook integration in the warehouse and a code migration assistant. In terms of the SQL engine, we will soon support Varchar Max, so lobs, Z ordering support, time travel using T-SQL. So I mentioned time travel with clones. We'll also support time travel with as of or at querying. Undo drop tables, so for those accidental drop scenarios where, oops, somebody's dropped a table, you can quickly recover that with an undo drop. We'll also have a support for session scope temporary tables, result set caching. The estimated query plan will be something available to you to view as well. And automatic stats when data changes. So a lot to look forward to for the Fabric warehouse. So hopefully you've enjoyed all these fantastic announcements. Thank you for your attention over the past hour and a bit. I would love for everybody, if you haven't already signed up, please go ahead and sign up for your free trial and put into action all these features that we've been talking to you about today. If you are excited about the mirroring preview, which Priya spoke about, please do sign up to the preview. We will be running a private preview for that. We invite you to submit your nominations. And that's pretty much it from me. So thank you so much. Also, we'll be around if you have questions, if anybody has any questions. But thank you very much for your time.